All right, we're looking at applications of geometric and arithmetic patterns. Let's assume we have $1,000 in our bank account at 4% interest per annum. Remember, per annum means you will be earning 4% per year. Now we're going to compound this money annually. So you're going to get paid interest once a year. Find the value of this account. After 1, 2, and 3 years. If we treat this like a sequence, then we can consider U1, the value initially, to be $1,000. So after 1 year, in our sequence is going to be U2. So after 1 year, we have $1,000 that has been earning 4% interest. So remember from our exponents and logs chapter that in order to grow, we have to have a base that is greater than 1. So I'm going to multiply 1,000 with 1.04. It's only been in there for 1 year, so that's all that's happening. And I'll end up with a value of $1,040. After 2 years, we're looking at U3. We still started with our $1,000. We earned 4% for year 1, and then we earned another 4% for year 2. Recognize that multiplying 1.04 with 1.04 is the same as saying 1.04 to the 2. If we button mash that in our calculator, and we're going to have $1,081.60. After the 3rd year, of course, is the same kind of idea, except we are now multiplying 1.04 3 times, otherwise known as 1.04 to the 3. And the final value after that is 1,124.86. Now, it's my hope that you can see how this is resembling a geometric sequence. The difference, the common ratio, is 1.04. I'm multiplying it by 1.04 each time to get to the next year. In addition, you can also see that UN is equaling U1, the $1,000 that I had originally, multiplied by my common ratio, which was 1.04, to the n minus 1. Yes, it's n minus 1 because when it's year U4, the 4th term, notice we had an exponent of 3. 4 minus 1 is 3. Now, we can play with that in terms of a geometric sequence, but we can also play with it with the formula that we had from the chapter previous with exponents and logs. The compound interest formula, remember, I wrote it down as final amount equals initial amount times by 1 plus r over n, and we're dividing this interest rate by the number of compounding periods in the year, right? So if we were compounding quarterly, let's change that. Let's say compounding monthly. That means that our interest rate, which was 4%, needs to be divided by 12 because we're splitting this 4% into 12 equal portions being paid out during the year. And our exponent with compound interest has to be the number of compounding periods multiplied by the number of years we left it in for. If we were compounding monthly and we left it in for 2 years, then we are compounding our money 24 times. So you should be able to do the next 2 questions using the skills from our previous chapter. Now would be a good time to press pause and try the next 2 questions and see if you can match up with my solutions. I've deposited $1,000. I'm earning 4% interest. That is 0.04 in decimal form. It's compounding quarterly, which means I'm getting 4 payments per year. So I must divide the interest rate by 4%. Recognize that BEDMAS says we divide this before we add it with the 1. We are leaving it in for 10 years, so my exponent has to be 4 because it's multiplying, or it's compounding 4 times a year, multiplied with 10 because it's in there for 10 years. If you solve that correctly in your calculator, you should get $1,488.86. The population growth. Yes, this is geometric in the sense that it's increasing by 2% per year. We are multiplying it by a common ratio of 1.02 every year. But it's easiest just to continue on with the formula that we played with. A equals A naught G to the little t over P. Now remember, we talked about another formula that was A equals A naught E to the RT. But this formula was used if the question used the word continuously. Remember, the E formula represents continuous growth, and that's much more accurate, but we want you to decipher between when to use the E formula and when not. So in this case, the word continuous has not been used. Where initial population is 12,500. Our growth factor is 1.02. Remember, in order to grow, it has to be greater than 1. And we are growing from 1980 to 2020 is 40 years. The P is the period, meaning how long did it take for this 1.02 to occur? Well, that occurred per year, so that would be a divide by 1. And we should end up getting an answer properly rounded at 27,600. With that, you should be able to complete 6L. You might be using our knowledge from exponents and logs and our knowledge of geometric sequences and series.